Hello everyone, I am Sayyed Tazen from Bundelkhand University, Jhansi. Now today topic is Thevenin theorem. Uh, Actually, this theorem is used for simplifying the circuit and to calculate the current and voltage in particular branch. So, if we use a complicated circuit, then it could be simplify with a voltage source and in series with the resistance using Thevenin's theorem, and we can calculate the current in that particular branch by using only a one source and one resistance only. So, let us start the theorem. So, any linear circuit containing several voltage and resistance sources can be replaced by just one single voltage source in series with a single resistance connected across the load. So, this first statement, first line is the validity of this circuit, which is a linear. It is applicable on the only on the linear circuit, and we simplify the complicated network which has several voltage source and several resistance into a single voltage source and a single resistance. So, that we can find easily a current and voltage in particular branch. So, this is the equivalent circuit diagram of the Thevenin's theorem, which is a voltage source, a complicated network across a load A B can be converted into a single voltage source V s, or we can say that it is a V t h, that is a Thevenin voltage, and in series with the resistance, which is also called as Thevenin resistance R t h in connecting with the load. So, let understand this Thevenin's theorem using taking a one example. Here 12 volt source in series with the 1 kilo ohm resistance, and there is a 100 ohm and 2 kilo ohm and 1 kilo ohm, and we find the current through 2 kilo ohm resistance using Thevenin theorems. So, first we have simplified the circuit using a single voltage source and a resistance in series, and here we find the current at 2 kilo ohm. So, this 2 kilo ohm is our load resistance. It is a 12 volt source. Here the resistance is 1 kilo ohm, here is 2 kilo ohm. Here we find the current at this 2 kilo ohm resistance. This is 100 ohm, it is around 0.1 kilo ohm, and this one is a 1 kilo ohm resistance. So, for we have just first calculate the Thevenin voltage and then a Thevenin resistance. So, for calculating the V t h, which is a Thevenin voltage, we have just open circuited the load resistance and redrawn the circuit as shown this. So, just remove the 2 kilo ohm resistance across A B, which is a open circuit, and this is a open circuit voltage across A B. So, it is V t h. So, we just find the calculate value of V t h. This one is 1 kilo ohm. So, suppose the current from the source is I. So, first we calculate the value of I, and then so we have find the mesh analysis in this loop number 1. So, by using KVL on applying the KVL at the whole circuit. So, 12. So, if we move the battery from negative to positive, we just take the value of plus 12 volt, and the current, if our direction loop direction is similar to the current direction, then it is taken as a positive. So, I into 1K and this in series I into 100 ohm plus I into 1 kilo ohm. Now, converting this resistance into a kilo ohm and taking I as a common. So, it is 1 and 1 is 2 and it is 0.1 kilo ohm. So, this is 2.1 kilo ohm. So, I will be around 12 upon 2.1 kilo ohm. So, it is around 5.9 milliampere approx. So, the current from the source will be 5.9 milliampere. Now, taking this small loop from 12 volt to VTH. Now, we calculate the value of VTH. So, it is around 12 minus VTH equals to I into 1 kilo ohm. Now, putting the value of I here in this equation, we can find the value of VTH. It is around 12 minus 5.9 equals to VTH. So, VTH equals to it is around 6.1 volt. So, this is the method where we find the Thevenin voltage VTH using this procedure. Now, next we have find the value of RTH. For this, we just redrawn the circuit with all voltage source are short circuit. So, this voltage source is short circuit 12 volt and this is 1 kilo ohm. Here we find the equivalent resistance from A to B. This is RTH. This is 100 or we can say that 1 kilo ohm, 100 equals to 1 kilo ohm and this one is 1 kilo ohm. So, for this 1 kilo ohm and this 1.1 kilo ohm and 1 kilo ohm are in series. So, RTH will be so, for finding the net RTH, the 1.1 kilo ohm and 1 kilo ohm are in parallel. So, the formula is 1 kilo ohm into 1.1 kilo ohm upon 1 kilo ohm plus 1.1 kilo ohm. So, it is around 1.1 into 10 to the power 6 upon 1 kilo ohm is equivalent to the 10 to the power 3 ohm. Now, this is 2.1 kilo ohm which is equivalent to 10 to the power 3. Now, 10 to the power 3 cancel 2. So, it is around 1 by 2 it is 0.5. So, it is around 0.48 kilo ohm. So, RTH is 0.48 kilo ohm. So, the equivalent circuit will be like this VTH and in series with the RTH and the load resistance. This is around 2 kilo ohm across AB. So, value of RTH is around 0.48 kilo ohm and value of VTH is around 6.1 volt. So, if we find the current through 2 kilo ohm, now you can see that the circuit is simplified using a 1 voltage source and a 1 resistance RTH in series and it is connected across the load. So, if we find the total current across 2 kilo ohm, so the formula is VTH upon RTH plus RL. So, VTH is 6.1 volt upon 0.48 kilo ohm plus 2 kilo ohm. So, it is around 6.1 volt upon 2.48 kilo ohm. So, this is around 3 to the 6. 2.3 milliampere. So, this is the current. We find the current using Thevenin's theorem by simplifying the circuit using one voltage source and a one resistance. Okay, thank you.